Calculate the dynamic viscosity of an oil which is used for lubrication between a square plate of size 0.8 meter by 0.8 meter and an inclined plane. So we have to calculate the dynamic viscosity of an oil, which is denoted by mu. Okay, we have to find mu. Uh, in the question, which is used for lubrication between a square plate of size and an inclined plane. Okay, so this is a diagram. Okay, we have to find the mu viscosity of dynamic viscosity of an oil. So this is a square plate of 0.8 meter by 0.8 meter, and this is the inclined plane. Okay, and in between this the oil is applied, which is it is which is viscosity of an oil which is used for a lubrication between a square plate. So here oil is applied, we have to find the dynamic viscosity of this oil, okay, in between the plate and in between the inclined slope. Okay, further the question is inclined plane with angle of inclination 30 degree as shown. The weight of the square plate is 300 Newton. Okay, weight is given as 300 Newton here, and it slides down the inclined plane with a uniform velocity of 0.3 meter per second. Okay, this is a square plate. Okay, and this is moving downwards with a speed of 0.3 meter per second, like 300 mm per second. The thickness of the oil film is 1.5 mm. Okay, the oil film which is applied here is the thickness is 1.5 mm. Okay, so the terms highlighted, we have to know this first. Okay, dynamic means, here the definition of the dynamic, it's changing. Okay, dynamic means in changing, and static it is unchanged, it remain fixed. Okay, in same, it is same, and dynamic means changing. Just keep in mind that static is unchanging and dynamic is changing. So calculate the changing viscosity. We can see this like dynamic means changing. Calculate the changing viscosity of an oil. Okay, for the sake of understanding, we have to just understand the dynamic term. What is mean by dynamic? So it's changing. Here we have to find the dynamic viscosity of an oil, mu. So first understand the diagram. What is given in the see, I have drawn the square plate 0.8 meter but 0.8. This is the top view and this is the side view. Okay, the plate is moving downward here. Okay, the plate is moving downward here with a speed of 0.3 meter per second. The dimension of the plate is 0.8 meter by 0.8 meter. Oil film is applied. Okay, we have to find this viscosity of the dynamic viscosity of oil, and this is the inclined plane. The weight of the plate is 300 Newton, and angle of inclination is 30 degree. Area of the plate is given. Okay, angle of plane 30 degree, weight of the plate 300 Newton, velocity of plate 0.3 meter per second. Thickness of oil film T is equal to dy is equal to 1.5 mm. Okay, 1.5 mm is there, so we have to convert it into the meter. So we have 1000 will be written like this, and 10 raised to 3 will come in the numerator, so we can write in this term 1.5 into 10 raised to minus 3 meter. Okay, so we have converted the mm into the meter. So we have to find the dynamic viscosity of oil mu. Okay, we have drawn the diagram. So okay, in the diagram this is a trigonometric formulas. Okay, for the sake of understanding purpose only, we have not to write it. Okay, as 30 60 90 theorem is also given. Okay, 30 degree angle of inclination is there, so the opposite here 60 degree will be there, and 90 30 60 90 theorem. Okay, and the opposite side will this angle will be also the same. So we have to we have drawn this diagram. So component of weight W along the plane. Component of weight W along the plane. This is the weight of the plate, 300 Newton. Okay. So component of weight along the plane. So along the plane it is W sin theta, but perpendicular to the plane will be W cos theta. So component of weight W is perpendicular to the plane. Okay, so this along will not come, it is perpendicular to the plane. Component of weight W is perpendicular to the plane, so we have to write like W cos theta, W is 300, and if we take W sin theta along the plane, so if we write along, so we have to here write W sin theta and put the value of sin theta here and calculate. So cos theta is half, okay, as per rule, trigonometric rule, so 150 Newton will be the answer. And if sin theta along, if we want to take along this along the slope along the plane, okay, it is perpendicular, we have taken the perpendicular to the plane, but if we want to take along with the plane, so W sin theta will come. So 150 Newton will be 150 Newton is the answer. Here two statements you have to remember, okay. The component of weight along an inclined plane is W sin theta. If we are calculating like this, okay, here, so we have to take W sin theta, but we are calculating from here perpendicular to the plane. Component of the weight perpendicular to the plane, so we have written as W cos theta. So don't confuse in this that where W cos theta is from where the W cos theta is come. So it's come like if we take from the second statement, the component of weight perpendicular to the inclined plane is W cos theta. So we have written here is W cos theta. Okay, so just remember these two statements. If we are taking along the plane, so W sin theta, and if we are taking perpendicular to the plane, so W cos theta will come. So we have calculated cos 60 is equal to 1/2 as per rule. So 150 Newton is the answer. So these two statements you have to keep always in mind while calculations. While calculations, you have to keep always in the mind these two statements. Okay, so next step is shear force on the bottom surface of the plate is 150 Newton. Okay, bottom surface of the plate we have calculated, we have removed the remove the force. 150 Newton is the answer. Now we have to calculate the shear stress. Tau is equal to force upon area, 150 Newton. We have got the plate force and area, so we have removed the shear stress, 234.37 Newton per meter square. Now using equation, this is the equation we are using in all of the numericals. So tau is equal to mu du by dy. So value of tau 234.37 I have noted down here is equal to mu. Mu we have to find this mu. Du is 0. Velocity of the plate. Okay, velocity of the plate is 0.3 meter per second. You can see in this diagram 0.3 meter per second is the velocity of the plate, and dy is thickness of the oil. Okay, thickness of the which is given in the question. You can see this from here. Thickness of the oil film is 1.5 mm. So it is given in the question. So 1.5 into 10 raised to minus 3 meter is there. So just remember how to calculate it and how to put them in the calculator. So just understand this is a mathematical rule. Okay, the thing in the numerator will goes to the denominator down, 234.37 bottom, and the thing here will come beside 234.37 as per mathematical rule. So please don't confuse in the calculation. One confusion will lead to all the answers wrong. So please don't confuse it. I have drawn the arrow from where the value is given. So 234.37 Newton per meter square multiply by 1.5 into 10 raised to minus 3 meter. Okay, divide 0.3 meter per second will come down. Okay, and mu is equal to mu. Okay, mu will be remain at that position only. So cancellation will be done, meter cancelled. Okay, so now remaining Newton meter and meter per second. So calculate like this. Okay, 234.37 multiplied by 1.5 into 10 raised to minus 3. It's come in the bottom 1000 and divided by 0.3. Now mu the answer will be 1.17 Newton second per meter square. So 0.351 by 0.3, okay, 1.17 Newton second per meter square. Okay, here the meter will come down and second will come beside the Newton. So last we have to mu, the value of mu within poise. Okay, so 1.17 Newton second per meter square we have got, but we have to convert the in poise. So to convert in poise we have to multiply by 10, as we know that one poise equal to 1 by 10 Newton second per meter square. Okay, 1 poise is equal to 1 by 10 Newton second per meter square. So mu is equal to 1.17 Newton second per meter. So we have to convert by multiplying by 10. So after multiplying by 10, we will get 11.71 poise. So the dynamic viscosity of oil is 11.71 poise. So if any confusion in the question, any of the confusion in the question, just make in the comments. Okay, I will resolve it.